let's start by reviewing what like terms are. So remember that like terms have the same variable, but they're also raised to the same exponent. So an x is not a like term with an x squared. And then distributive property is when we take the outside number or value, because sometimes it's not a number, and we multiply by each inside value. So like if I had 3 times the quantity x plus 2, we would take 3 times x, and that would give us 3x, and 3 times 2, that would give us a positive 6. Okay, so when we're solving equations that involve combining like terms or distributive property, we would want to either do that combining or that distributive property first before we begin solving that equation. So in number 1, for example, I would want to combine these like terms. So a 2x plus a 3x, that's a 5x. And then we bring down that equal to 5. And then once we are done simplifying our equation, then we can begin to solve it. So now we're going to solve this like normal. This happens to be a one-step equation. We would divide both sides by 5. And x equals 1. In number 2, I again see that I've got some like terms. I have 4x and 3x. So I can combine those like terms. 4x plus 3x is 7x. Then I bring down everything else. Minus 9 equals 5. Now, even though the negative 9 and the 5 are like terms, they're on opposite sides of the equal sign. So we cannot just combine those. So when we say we're combining like terms to simplify, it's only on the same side. So let's make a note to only combine like terms on the same side of the equal sign. If they're on different sides of the equal sign, we'll eventually get those combined by solving the equation, like we're going to do right now on number 2. Now this is the two-step equation, so to get rid of this minus 9, I have to add 9 to both sides. This cancels out because that makes 0. And now we have 5 plus 9 makes 14. Whereas if I had accidentally added that together, negative 9 and 5 would have been negative 4. So definitely a different answer. So if they're on different sides of the equal sign, we have to do that solving when we're doing the opposite operation. And now I can continue solving this. Divide both sides by 7. So x equals 2. 14 divided by 7 is 2. Number 3, we have distributive property. So I'm going to do that first. 2 times x is 2x. And then 2 times negative 4 is negative 8. And then we stop distributing. Remember, when we have that parentheses, we only multiply what's inside the parentheses. So I'm just going to bring down my equal to 2. Now, if I look at the left-hand side, 2x minus 8, no like terms to combine. If I look at the right side, 2, no like terms to combine. So now I'm going to begin solving this equation. We're going to add or subtract first. So the opposite of minus 8 is plus 8. This cancels out because I make 0. 2 plus 8 is 10. And then my last step is to divide both sides by 2. X equals 5. On number 4, we do still have distributive property. It does look a little bit confusing because of the fraction, but it's still going to work the same way. So we're going to take the 1/3 times x is 1/3 x, and 1/3 times 6. And we can do some scratch work over here. 1/3 times 6, well, that becomes 6 over 1. And then you multiply straight across. 1 times 6 is 6. 3 times 1 is 3. And 6 over 3 is just 2. So that 1/3 times 6 is really just 2. So we bring that 2 over into our problem. And then we're done distributing. And we still have that equal to 1. Now I've got a two-step equation solved. So we always want to undo addition and subtraction first. So So I got to get rid of this plus 2 by doing minus 2 to both sides. We always got to keep it balanced. This cancels out because it makes 0. So I still have that 1/3 x is equal to 1 minus 2 is negative 1. And then with the fractions, this fraction, this 1/3, is multiplying x. So the opposite is to divide by 1/3. I'm going to write dividing this way. Divide by 1/3 and divide by 1/3. Then I'm going to do some scratch work. So I'm going to write it out the other way. Make sure that looks like a division sign. Okay, so we have, I'm just going to take this part right here and do this workout. So I have negative 1, and I'm going to divide it by 1/3. Well, we divide fractions. Let's make this a fraction first, negative 1 over 1. We keep that fraction the same. We change to multiply, and then we flip, so it becomes 3 over 1. And then we multiply straight across the top. Negative 1 times 3 is negative 3. And 1 times 1 is 1. And negative 3 divided by 1 is just negative 3. So for all of this, after I do this, I just end up with x equals, because this canceled, so I just have the x by itself now, equal to that negative 3 we just got. On number 5, I noticed two things. I noticed that on the left-hand side I have like terms, 10x and negative 3x make 7x. But I also noticed on the right-hand side I have like terms, 20 and 1 are also like terms, and that makes 21. So we always want to do all our simplifying first on both the left and the right. If you can simplify, that means combine like terms or distribute, then we're going to do that first. Now we're done with that. No more simplifying, so we're going to solve. Opposite of multiplying by 7 is to divide by 7. That cancels because it becomes 1. X equals 27, or 21 divided by 7 is 3. On number 6, I see distributive property. I always want to take care of distributive property. It always comes before combining like terms, just so we can see all the different terms that we have. So when I do this distributive property, I have 2 times x is 4x. 2 times positive 9 is positive 18, and then we stop multiplying because that's our only distributive property. So this minus 1 is not going to change, and we still have 16 equals out front here, so that's not going to change either. And now we're going to look, and I see I've got some like terms. I have a positive 18 and a negative 1. And even though, yes, 16 would be a like term, remember that's on the different side of the equal sign, so we can't include that. We can only simplify this on the same side of the equation. So the 16 is all by itself. There's nothing to combine it with on the left. On the right, I do have that 18 minus 1 is 17. And now I can begin solving that. All my simplifying is done. I can begin solving. So we need to do add or subtract first. So I'm going to get rid of this positive 17 by doing negative 17 or minus 17 to make that 0. 16 minus 17 is negative 1. And then I have 4x left here. And then we're going to divide both sides by 4 to get rid of that 4 from the x, to get x all by itself. And then when we have a fraction like this, it doesn't divide equally. You can just leave it as a fraction, or you could divide it. That would be negative 0.25, but it's just as easy to leave it as the fraction. And then for our last question, a rope 25 feet long is cut into 3 pieces. The first piece is 2x feet long. The second piece is 5x feet long. And the third piece is 4 feet long. So we're going to write an equation. So if I have a whole rope, I take all 3 pieces and put them back together. So the first piece was 2x, plus then I add the second piece, which was 5x, plus then I add the third piece, which was 4. So I take all 3 pieces together, should equal my total rope, which was 25 feet long. And then to find the lengths of the first and second pieces, then I've got to first find out what x is. So let's solve this problem that we wrote. So 2x plus 5x is 7x. We still have plus 4 equals 25. And I can finish solving this. We're going to subtract the 4 from both sides to make that 0. 25 minus 4 is 21. divide both sides by 7. So we get x equals 3. Now we didn't answer the question yet. It says find the lengths of the first and second piece. So I know that the first piece was 2x, and now I know that x is 3, so that's 2 times 3, because 2x means 2 times x. So 2 times 3, so the first piece is 6 feet. And the second piece was 5x, or 5 times x. So that's 5 times, again, x we found out was 3, so that's 5 times 3, or 15 feet, will be the length of the second rope. Then add any other notes you want to, but remember we're going to simplify on each side separately. We can't simplify across an equal sign, so with just the left and just the right, before we begin solving our equations.